Where's the teacher? There he is. Okay, we have been given a sequence, and that sequence is defined recursively. What does that mean? Okay, so far we've talked about the word explicit, and we have not talked much about the word recursive. And recursion is when we have a sequence and we are going term by term by term. If you want my opinions, which are mostly irrelevant, but if you want my opinion, recursion is a very slow and painful process, and it's not always the best thing to do. So we don't use recursive formulas very much. So here's the deal. If I'm going to define something recursively, I need a couple things. I need to know where to start, and I need to know how to keep going. I need to know where to start. Let's just go ahead and jump into the first problem. Where do I start? I start with 8. How do I keep going? Well, then what's the pattern? So first term was 8, and the next term is, oh, this is a little wordy. Okay, c sub n plus 1 equals 1/2 c sub n. Don't panic. Whatever term I'm on, we'll call it the nth term, that's this. If I want to get to the next term, so like what happens after n? Don't say O. But what happens after n? N plus 1. So like if I'm on the nth term, then the next term, the n plus 1th term, is half of the term that was before it. So if I want the next term, take half of 8. If I want the next one, take half of 4. If I want the next one, take half of 2. If I want the next one, well, I don't want the next one because I only wanted the first 4 terms. So it's worth writing here that c sub n plus 1, this little notation down here, means the term after the nth term. So whatever term I'm on, it's the next one. Now, sometimes I have seen c sub n plus 1 here, and that would be a c sub n. I lied. C sub n minus 1 here, and this would still be one more than that. So it would always be the next one. Okay, that is basically the next term. I could word it differently and say it's the next term. So write the explicit formula. Well, now we have something that just is a little more easy to look at, in my opinion. A little easier to look at, if we're going to use the correct grammar, proper grammar. The explicit formula for a geometric sequence. This is geometric because we're multiplying by 1/2 every time. Fairly obvious. The explicit formula, we wrote this on the previous problems, a sub 1 r to the n minus 1. And if you forget that, it's okay because it's kind of common sense. So explicit formula, we're going to call this one c, not a, but that's okay. So c sub n, any term I want, I'll need to know where I start and how I keep going. But then, how many times am I going to multiply by 1/2? I will multiply by 1/2 one less times than I would need to get the term I want. That makes sense. Now, let me try this again. You want the 10th term, you need to multiply by 1/2 9 times. You want the 100th term, you'd have to multiply 99 times. So n minus 1. There we go. I want to keep going with this because manipulating these formulas is going to come in handy later. So let's keep moving. Totally okay, completely acceptable, but let's keep going. This is equal to 8 times, oh goodness, should we? We should. 1/2 to the n, 1/2 to the negative 1. Because it's fun, let's do it. Totally okay, you can do that. Separate these because if you put them back together, it'd be n plus negative 1, so n minus 1. So 1/2 to the negative 1 is reciprocal of 1/2, which would be 2. So I really have way too much handwriting here, but we're going to keep going with it. So 16, 1/2 to the n. That does not mean my first term is 16. My first term is 8. But if I plugged in a 1 right here, then I would get 1/2 times 1/2 to the 1, which would be 1/2, and then 16 times that would give me 8, which is my first term. This is acceptable. This is acceptable. These are just sloppy, but they're acceptable. Okay, find the limit as n approaches infinity of c sub n. So what's the pattern? This is where you just start thinking, well, if I had to write this all day, what would I end up getting? What would I approach? 8, 4, 2, 1, 1/2, 1/4, 1/8, 1/16, 1/32, stop and think, 1/64. What are these numbers approaching? They're approaching 0. they're approaching 0. And on the previous problem, we went through this process in a lot more detail. We were like, oh, it's the limit, as in approaches infinity, of 8 times 1/2 to the n minus 1. And we worked through all the stuff, and it was fantastic. It's 0. It's 0. These numbers are approaching 0. Okay, find the partial sum, s sub 10. We're going to add the first 10 numbers. I'm going to erase what I have so far and just create some space. I am going to keep that because that's a lot more practical. Actually, let's erase that too. We'll put it up at the top. So 8, 4, 2, 1, 1/2. You know, we could just list the first 10 terms, or I could give you the formula. Why would I want to do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 2, 3, 4, 5, 6. It's 10 for sure. Am I doubling correctly? I believe I am. Yep. Okay, we're good. Let's add those together, shall we? I think we should. There's a formula for this. I am going to throw it at you in just a second, but in the meantime, I am going to just go ahead and give you the answer, which I'm not going to even waste my time typing. It is 15.98437.5. I went beyond 3 decimal places, but that's okay. So there it is. That's good to know. Okay, so as I add more and more terms, I'm adding terms that are approaching 0. And because I'm adding terms that are approaching 0, this doesn't always work, but for now, with our level of understanding, we'll say it, as we're adding more and more terms that approach 0, we are more likely, I should say, to converge on a specific sum. And using our rounding skills, that sum would be what? 16. So find S, the infinite sum would be 16. Okay, time for a formula. Do you have to memorize it? Not necessarily. No, I've never really seen this one become a necessary thing on the AP exam. But the sum of, and I'm going to write down what it is, the sum of a finite geometric series is just good to know. So here goes. The sum of the first n terms for some geometric, and this was geometric. Geometric means we're multiplying by the same number every time. Arithmetic is when we're adding or subtracting the same number every time. We are adding a negative if we're subtracting, but whatever. 1 minus r, 1 minus r to the n, and then a 1 goes there. So that's it. Just good to know. There you go. If you wanted to, you could, and I might in a second if I want to prolong this video. I could plug those numbers in. I could put an 8 right here, 1 minus r. R, what's r? R is what I multiply by every time. It was staring me in the face from the beginning, and n would be 8. And it would work. I could type it in, and trust me, you would get something super close to 16. I won't type it in. Unless you want me to. Do you want me to? Nah.